Here we have a mathematical operation, right? 4, what is happening there? No. You're all jumping the gun. I want to know the simplest answer to the question I just asked. What is happening right there? Connor? Multiplying. That's all I needed, right? Okay. What do these brackets do to x minus 5? They keep it together as one thing. Why is there an x there? Because we don't have a number for it, right? So this part of this expression is some unknown number then from which we are going to remove 5. Everybody cool? So, if I told you that x equaled 11, then what would this be? It would be 4 times 6, correct? And 4 and 6 would give me 24. Which are the factors and which is the product? Armand. Because 11 minus 5 is 6. Which are the factors and which is the product? She too. 24 is the product, yes? Now, if I wish to find the factors of 24, I must do what math to 24? Division. Everybody cool? All right. So, now get slightly more complicated. What is the verb that we use for doing this multiplication when we have an unknown number? Mantage. That is the distributive property. And what is the answer? What is the product of these two factors? 4x minus 20. Now that is when you have done it in your head, and of course you are all more than capable of doing that. I would submit that you should remember that it is 4 times x plus 4 times negative 5, which gets me 4x plus negative 20. And math people, being what they are, do not like that notation, so they invented that. Is everybody good? Excellent. Factors on this side, product on this side, right? Excellent. Now, what do we have here? Factors or a product? Factors, because this factor 1 is going to multiply by this, factor 2. And this, of course, is an example of the distribution property done twice. It gets from 99.9% of math teachers a fun little acronym, FOIL. I, of course, don't like that acronym because it only works with binomial and binomial. This happens to be binomial and binomial, so it's okay to use it. But don't fall into the trap of first, outside, inside, last if there is more than a binomial and a binomial. Learn what is actually happening. And what is actually happening is the x distributes twice and the 4 distributes twice. And I get I want all of it.
X squared plus 2x plus 4x plus 8. Should I keep on going?
Nope. Everyone's good, right? Everyone can expand, yeah? Okay. We're going to come back to that, even though a great many of you probably know where we're going. I do not care because I was not your grade 9 teacher. I have to make sure we are all on the same foundation. In the last unit, when I said factor 12, what did that mean you did? Mantaj, again. You made a factor tree to get to the prime factors, yes? And those prime factors were, of course, 2 squared times 3, right? Excellent. That is last unit, or the unit that you will be tested on Friday. This unit, when I say factor 12, it means I am seeking all, underline all, Mrs. Bad Crumble Cloud, all, highlight all, pairs of factors that equal 12. That is this unit. Now, what is the first pair of factors for 12? 1 and 12. Good. Everybody forgets 1 and 12. What is the next ones? 2 and 6. What is the next ones? 3 and 4. Now, please notice something. All of those are integers, aren't they? Yes. Could there be a fractional factor of 12? Yes, because isn't 24 times 1/2 12? So, not only do I want all the pairs of factors, I want them to be integers. That's what I mean in this unit when I request for you to give me factors. Does everybody understand? Yes. Excellent. Now, to be successful in this unit, you must be good at multiplying. And when I say good, I mean good. I mean, if I gave you a mad minute with 2-digit multiplying and I gave you no calculator, you would actually get the whole page filled in the minute. Okay? I know you've all done at least one mad minute in your life. Yes, Mantaj. This unit, I just crammed it together. That is this unit, whereas this was last unit. How can you be confused? Mantaj was asking what that word over here, because I'd written this unit and I didn't put any space, so it was this unit. Okay. All right. Now, I know that we have already talked about using algebra tiles. We drew it last unit. Hey, Miss Bernini.
Hey guys, how we doing?
We seem to be in good spirits.
Are we okay? Thumbs up?
We have a couple that are out and about, but we have a couple that are out and about, but they checked in with me first, and I know where they are. Where was I? Algebra tiles. Did I tell you the mermaid joke yet?
No. Oh yeah, you did.
Okay. Yes. Okay. Now you all know that I know that you don't like algebra tiles. And you all know, or I know that you all know, that I don't like algebra tiles. But you all know that I know that I'm told that I got to show them to you. Yeah, but this is a different application of them. All right? What we are not going to do is actually play with them again. Okay, so this verb says factor, which must mean I don't have any factors, do I? Because the verb is telling me to get some factors. Armand, that is your desk over there. Get your stuff and move now. You have 3 seconds before you're moving outside of the room.
Which one?
Back corner. The next time I look up, it is going to be one of the next 6 of you back there. And to move you far away from him, I will have to move somebody else who is showing me respect, which pisses me off, because they shouldn't have to move from their friends because you 6 can't keep your crap together. Got it? This is when all 6 of you nod. Good. Now, as I was saying, we are going to break this down into factors. What is required to make a factor? Division. We all know this. So, if we were going to use algebra tiles, which we are going to use twice more and twice more only, I'm the worst kind of liar. I think we're going to use them thrice more. We got to break this down. Now, every product in math, no matter what the number is, give me a random number. 7. 7 is a number. It can be broken down into factors. 7 was a good one because it only has 2 factors. It is 1 and 7, which means that that integer can be shown as a picture. 1 wide, 1, 2, 3, 4, 5, 6, 7 long. We can make a rectangle. Every number can make a rectangle, right? Now, if you know what x is, then doesn't this make a number? Of course it does. If I told you x was 2, then that's 15, right? And we can draw 15 as a rectangle. How many different rectangles could we draw? 2. 15 by 1, 3 by 5. Everyone good? Okay. So if this is indeed just a number, this too must be representable by a rectangle. Agreed? All right. So it is split into 2 different kinds of algebra tiles. The x's are the skinny bars. Are they shaded or not shaded? Not shaded, because I need 6 of them. Right there, that's a rectangle, yes? It's 1x long, 6 wide, right? Everyone agrees? Could I put it this way? Wait a minute, I made 7. Could I put it this way? Is that still a rectangle? Excellent. Could I put it, let's go back. Could I put it this way? Yes, because that's a rectangle that way. Everyone agree? Excellent. What are these guys? The little squares, colored or uncolored? Excellent. 3. Is that a rectangle? Excellent. Could I do it this way? Do I have any other options? No. Everyone agree? Okay. So now, put them together. 6 x's and 3. Does that make a rectangle? Not in my world. That looks like a P. Okay. That's no good to me. Figure it out. Make this into a rectangle. Go. Make this into a rectangle. I want to see what happens. Okay? Want to draw it?
I can tell you what it is. I can't draw it.
It's rectangles, dude. Okay, Jordy, come on up.
Okay. Can I start up there?
You put wherever you want to, buddy. It's your canvas. Far be it for me to tell you how to express yourself.
3, 4, 5, 6, 1, 2, 3,
Excellently done. Is that a rectangle? Excellently done. Just wait. So, just wait. So there's our rectangle. Hey, have I told you I'm happy?
No.
Do you think I am?
No.
Good reading of nonverbal cues. 1, 2, 3. 1 x, 6x plus 3 times 1. Did Jordy find me any new factors? No, because 1 is a factor of what numbers? Every single number ever. So if I write this as that, have I factored it?
No.
No. So, Jordy, I will give you props for having the backbone to come up and give it a shot. Well done. But, excellent.
I have one.
Sure, Mantos, you've had your hand up a few times. So it's time. Normally I would bring it to you, but the microphone's plugged in and I'm charging. It's just a pain today. Wait, you don't want to sit in my chair. It'll be all warm from my butt. You stand. Well, it's the worst, right? Anywhere you want, sister. Express yourself. As the Madonna song says.
Did you please sing it for us? So that
Express yourself. You've got to make him express himself. Booyah, Grandma!
Let's go back. I did it wrong.
Now, stop for a second. Some kid always says, I did it wrong, Mr. Myers. I drew it this way. And is that wrong? No. Of course not, because once again, 1, 2, 1, 2, 3, 4. 4, how much is in the middle? 8. I love how long that took. Big surprise. That'd be quicker just to draw it. I was trying to find the rotate button. Where is it? Anyways, 2, 4. What's in the middle? 8. It doesn't matter. So, where? Oh, right up there. Yeah, I knew it was up there somewhere. Now, this is a product, yes? Just like the middle of the 8 was 8. Where do the factors live? No, we just said the factors are on the side. 1, 2, 3. What's that distance? X. What's that distance? What's that distance? 1. So the factors are 3 times 2x plus 1.
Wow.
Everybody good? Now, of course, that is the longest possible way to do factoring. There's a much quicker way. I'm going to wait till we do this one more time. Then I'm going to show you that way. Because that way, if anybody says, are you doing what you're supposed to be doing? I can say, yeah. Now leave me alone. Let's go. All right. Go. What do I got there? What do I got there? How do I draw those guys? A big one. Because it's got to be x long and x wide. How do I draw those guys? The skinny bar. I need 4 of them. I need 6 of them. Make me a rectangle. Go. I don't know why people get stressed out about this. I told you I don't even care. I'm only doing it because I have to. A square is just a very special rectangle. Dude, it should be a rectangle. I am not sneaking any mess into this. It's simply a rectangle. I am not going to trick you. I am not going to go, ha ha! Now you have to learn it in Greek. I'm just telling you to make it into a rectangle, man. Let's go. Let's go. Como's going to do it? Yeah, you are. Yeah, you are. Give me a K. Give me an O. Give me an M. Give me an A. Give me an L. What's that spell? Como! Let's do the wave. Ole, 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 ole. Ole, ole. Ole, 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 ole. Ole, ole, ole.
Okay, that was.
Goal! Let's go, Mom! All right. What are the factors? What are the factors? What's this? 2x. What's this? So it's 2x times 2x plus 3, right? Okay, I'm going to make you do this thrice more and then never again. Wait. Thrice, I'm going to make you do this thrice more and then never again. We love algebra tiles. Thank goodness somebody invented them and put them in the curriculum. Right, class? Yeah. Remember, loose lips sink ships, which is a pleasant, much more pleasant way of saying snitches get stitches. All right, here we go. You are going to learn in this grade 4 types of factoring of binomials. 4 types of factoring, good alliteration there. 4 types of factoring polynomials. This one is number 1 because of 2 reasons. 1, it's the easiest, and 2, you should use it all the time. Any chance, almost every polynomial has the possibility of being put through the greatest common factor. Okay? So let us talk about this. Well, let's see if I can make it make a little more sense. 9 and 12. What are the common factors of 9 and 12? This is easy to do in your head. You know as well as I do it is 3, right? Because 9 is 3 squared, 12 is 2 squared times 3, 1 3 is common, right? Of course, when they're little numbers like that, you can all do it in your head and you know, right? If I had 72 and 196, it might be a little more difficult, but you all learned how to do that in the first unit, right? Okay, so you can all tell me that. Excellent. Now, x squared and x. Now what is the common factor? Why? Because I have x and x there. Or, sorry, I have xx there and 1x there. There is 1x common, yes? Okay. What about x to the 4th and x to the 3rd? 3 x's are common because this guy is x, 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 and this guy is naughty, he's x, x, x. And you see there are 3 that are common. That's my favorite joke because it kind of rolls through the class like a wave. One kid gets it right away, and then like 3, 4, 5, 10 seconds later, somebody's like, like, what are you laughing at? Nah. I told that joke like 3 minutes ago. It's a crap joke. I don't even know why I keep doing it, but you all still keep laughing at it, so I'm going to keep doing it. Yeah, and you keep laughing at it. Yes, you do. X squared y and xy squared. This guy is xxy. This guy is xyy. What's common? One of them. Yeah? Excellent. So now, tell me, and I'm going to use brown because that's a mixture of all these different colors. Tell me what 9x squared y squared and 12x4y cubed.
I got it.
3x squared y squared. Can everybody do this?
Yes.
Yes? All right. Now, pretend that there is no addition sign there. Okay, what's the common factor? 5. Agreed?
Yes.
Excellent. Well done. You've passed grade 6. Now we're in grade 10. 5x plus 5. This looks a lot like what we just did, 6x plus 3, right? Okay. Now, am I going to make you draw 5 bars and 5 boxes? No. Why? Because we's grown-ups. Algebra Tiles is for preschoolers. Like that joke about, I can't even remember what TV show it was from. They were playing cards, and one kid asked, they were playing poker, and one kid said, they're all kids. He says, what's wild? And the other kid says, wild cards is for preschoolers, which I think was really funny. But that's neither here nor there.
I'm so...
No. Jewel, if you are going to be confused by me, let me give you this tip. If I am not looking at the page and actively writing something to do with numbers, then ignore every word out of my mouth, okay? Because everything else is just for entertainment, okay? It's the best advice I can give you. All right. So now, we know, because we were able to take 6x plus 3 and make a rectangle, we know we could make a rectangle here, yes?
Yes.
All right. So, here is how you do this in real life. Step 1. Decide on the GCF of all the terms in your polynomial. So you guys have already decided that that is indeed, in this case, 5, right? Because we're working with this one right here. Step 2. Divide, not decide. Divide. But see how it rhymes? Because rhymes help people remember stuff. Divide all your terms by the GCF. So I'm going to divide by 5 and I'm going to divide by 5. And finally, answer thusly. You write the GCF, bracket, and then you write, what is the answer to a division question?
Quotient.
Right. Quotient 1 plus or minus quotient 2 plus or minus. When do you stop? When you run out of quotients. Quotient n. So, I've chosen my GCF. It was 5. I've divided by it. It was 5. So now I write it as GCF. Quotient 1, 5x divided by 5 is x. Plus 5 divided by 5 is 1. And now I'm done. You all have seen this already. Most of you do it instinctively, but I like to have it codified before we go forward with more factoring. All right?
Yes.
All right. So, we've already done this one with Algebra Tiles. Let's do this with algebra, the way it should be done. Right, bruh? See, that was a joke. You shouldn't have paid attention to that.
I did it.
Excellent. And now you're not confused. Right? Right. So, what is our GCF? 3. So I then divide by 3 and 3. And then I write GCF 3, 2x plus 1. Easy peasy lemon squeezy, right? Great. Do the next 2. When you're done, pull on your nose. I always like to see how many people actually do it.
Oh.
No, I'm being serious. Because they teach you at teacher school that you guys are so scared to give answers that we should not be getting you to put your hands up and things anymore. We should be using nonverbal cues so I can look up and see that if everyone's doing this, you all understand. But of course, at teacher school, they forget that you have eyes too. And you will look and see all your friends doing this, and you will just do that whether you understand it or not. Because that's how kids are. So I like to make it fun, like pat your head and rub your stomach. If you understand. And then everybody does it. I like to start patting first, Jordy. I find that easier. But if you go the other way, pat your tummy and rub your head, I can't do that. I got to start with the rubbing then. I know, it's weird, right? If you move your finger clockwise, counterclockwise.
And then you try to move your feet clockwise.
Oh, yeah. We do that at karate. We try to get, when we're warming up, you try to get this hand, not like wax on, wax off horse crap, but get one hand going clockwise, the other hand going counterclockwise. And then, yeah, we do it. No. Because you start with that, and then he gets... Now, if your right hand is the clockwise one, you have to make your left foot go counterclockwise while the other one's working. Right? Yeah. Okay. So what's this one? I'm only going to write the answer in green. What's this one?
It's 3 out of the bracket x squared. Thank you. 4 x minus 2. 2. Oh.
And what's this one?
2x bracket 2x plus 3.
Great. Now, please notice I am going to a thick pen. Why?
Because it's important.
Always do this factoring, comma, anytime you can. What if you're in the middle of a question and you realize that there's a GCF? Should you get it? Yes. What if you're at the beginning of a question, you realize there's a GCF there? Should you get it? Yes. So when? Always. So all of you are able to do the first 2. Go. Decide on your GCF. What is it? 5x. Why is it only 1x? I can see there's y's all through there. Because this poor loser doesn't have any y's. He's got 2 x's, but no y's. He's not very wise. Why, oh why, does he continue to do all these puns? Why does this GCF only have one X? Because these guys can't keep a hold of a partner. They've already lost 2. This guy only has 1 X. See, you're not confused. You're tying it all together. All right. So now I divide. And what is my final answer in Kermit the Frog green? No, because my Kermit the Frog impression is not very good. My son does a spectacular Kermit the Frog. And I named my dog Cooper D. Dog. I said his middle name is Declan, so he is Cooper D. Dog, Cooper the Dog. And when he's in trouble, we yell at him with his middle name, just like we yell at the kids with their middle names. Cooper Declan! He stops listening at Cooper, like all dogs do. There was an excellent old cartoon back in the 80s. What we say to dogs. Bad dog, Ginger. Don't you eat my shoes, Ginger. That's really bad of you to do, Ginger. And then the next frame is, what dog's here? Blah, 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 Ginger. Blah, 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 Ginger. Because that's all dogs here. Because dogs is stupid. Number one way to get my class angry. I could talk about racism, sexism, climate change, all you like, whatever. Screw that. Don't worry. Dogs is dog. How dare you? They eat feces. Because I also have a family. Yes, Harry. How are words mean? Oh. Words are made like everything is made. Somebody says a sound once, associates it with something, and then somebody else agrees with that, and it becomes a word. That's why words are getting added to the English language all the time. That's why selfie is now a word now. Because somebody picked up their phone, thought the rest of the world gave a rat's ass what they were doing at that moment, took a picture of themselves, and put it on Instagram. Then somebody else said, oh, that's cool. I'm going to take a self-portrait of myself and put it on Instantgram. And then everybody said, oh, self-portrait's a lot of syllables, and I'm so busy. I only have 114 characters, so I'm going to make it selfie. And now it's a word. That's how all language grows. Strangely, most words in your lifetime, a lot of words will change definition, especially slang words. But my favorite slang word is cool, because it's been cool longer than every other slang word in the English language, because cool just means cool. It doesn't mean fat with a PH. It doesn't mean stupid with a PIT. It doesn't mean sick. It just means cool. And no matter how stupid the other words come, like in the 80s, you know what one of the words for cool was? No, tubular. Not a word of a lie. He's a tubular guy, right? Lame as crap. Just like, that's one of the reasons that I'm not a huge fan of the hip-hop genre, because they use current slang and current people in their songs. That's why their songs aren't timeless. You won't remember some song by some rap guy, especially a guy like Eminem, in 30 years, because all those people he's referencing don't exist anymore and they aren't cool. But the word cool is. That is why we are still listening to Led Zeppelin songs, Beatles songs, because they didn't do that. They were timeless. That's why Beethoven still sells albums, because it's cool. Yeah, what's Beethoven's Insta? So, Oh, I thought you said network.
No.
Oh, Beethoven doesn't have a net worth. He's dead. Okay? I'm sorry. He's dead. What? Sure. What is the GCF here? So what is the answer?
2 bracket 4 plus 5a plus 3a squared.
Excellent. Now, C is weird. What is weird about C? They're all negatives, right? So, what is technically the greatest common factor? No, I said the word technically. No. 5 is the greatest common factor because 5 has a higher value than negative 5, yes? So you all, if you are not thinking and just following steps, greatest common factor must take out biggest number, 5, C, D. But that would be wrong because there is a negative all the way through. So if there is a negative all the way through, math folk have agreed that you bring that negative out as well. So what this becomes, and I won't use Kermit D. Frog green because it's slightly different, it becomes negative 5CD. And now, what is this quotient? Positive 4C cubed. What's this quotient? Positive 6C squared D. What's this quotient? Positive 5. Now, again, there is something else weird that happens here. If this is positive, and you take out a positive 5, because you're like, oh, they're not all negative, I'm going to take out a positive 5, then you would be left with, and this time I'll use yet a different shade of green. I'm running out of shades of green. If I make that positive and I take out a positive, then I have negative 4C cubed, negative 6C squared D, and positive 5, right? Now, some math teachers would mark this wrong because they don't like that leading negative. Am I that guy?
No.
No, sir.
No. I'm tubular.
No.
Here's another one that was cool in the 80s. No. That's pre-80s. Beige. Beige. The color beige. If something was cool, it was beige. What about that one? Yeah, there isn't a greatest common factor, is there? Because 1 is everybody's factor. So this one is just does not factor. All right? Now, you have the rest of today. I know these say assignment. They're not an assignment. 74 and 75 are to be done for, start it now. I want them done tomorrow. You don't arrive in the morning. Wait, you do arrive in the morning. Tomorrow is ABCD. You start with me. When you walk in the door, those 2 pages need to be done. You are writing your test Friday.
Oh, sorry.
We're not writing it. Everybody decided they would rather write it Friday than first block. Huh? Remember I told you I was going to make you do it 3 more times? That's one of them. 1. Hey, Samuel, did your dad put me on his Insta? Then why did I do that? If I'm not getting likes, I'm not doing it.
Is that why you do YouTube?
I'm joking. This is something between Samuel and myself. Did you put it on your Insta?